So, you want to learn Web3. When I first got into Web3, I watched a ton of tutorials, but it was pretty confusing at the beginning. I had this idea that Web3 was supposed to replace Web2, but that's not the case at all. Web3 isn't here to take over, it's a completely different technology with its own unique strengths. It's not about replacing Web2, but about adding new capabilities that aren't just possible with traditional web tech. In this tutorial, I'm going to show you how you can create a simple Web3 voting app step by step so you can see what makes Web3 so powerful. Now let's talk about what makes Web3 different. In a Web3 app, there's no centralized server or database. Instead, everything is decentralized and happens on a blockchain. Smart contracts replace what we would normally use a backend server for, making transactions transparent and secure. Our app will use smart contracts to manage all the voting data, which means no one can tamper with the results. Before we dive in, here's a quick overview of what we will be building today. So, this is a simple policy creation app where users can propose a policy and other users can vote on any policy, and the admin can implement a policy based on number of votes it gets. Now, first of all, we need to connect our MetaMask account. So our MetaMask account is connected. Now, if we refresh, we can see all the policies. These are the policies that have been implemented, and these are the policies that are not yet implemented. So we can vote on them. If you have already voted, you cannot vote again. It will be disabled, and this implemented button will only be visible to the admin. I am the admin of this app, so it is visible to me. And if I vote on this policy, it will be disabled after I vote. Now, if I refresh, it will be disabled. You can see it has disappeared from here because I have already voted. Here it is. And if I click on implement, it will be implemented. And if someone wants to propose a new policy, they can enter the details here and they can submit the policy. Now if I refresh, the policy will be shown here. Here's a quick rundown of what we will be covering today in this tutorial. First of all, we will set up the development environment, installing MetaMask, connecting Polygon testnet with it, and then connecting Remix with MetaMask. After that, we will write and deploy our smart contract using Remix, and then we will build a front end using Next.js and connect our smart contract with it. So let's start by installing MetaMask. I will be installing MetaMask on Edge, but if you are using Chrome or any other web browser, you can find the extension in your browser's web store. Now, while I am installing MetaMask, let me tell you what it is. So, MetaMask is a crypto wallet, and we will be using it to make transactions in our decentralized app. Now, in decentralized apps, everything we do is done through a transaction. For example, if we vote on a policy, it's a transaction because we are changing some data in the blockchain. I already have an account in MetaMask, so I will log into my existing account. But if you are new to MetaMask, you will have to create a new account. As you can see, MetaMask has been installed in my browser and my balance is zero. But to make transactions in a blockchain, we need to pay some gas fee. But we don't want to use real money right now. So we will use Polygon's ZK EVM Cardano testnet, which is of course free. Now first of all, we need to add Polygon testnet to our wallet. For that, we head over to this link. I'll link this in the description. and we click on this button, it will open MetaMask and we can connect to the Polygon testnet. Now you can see I already have some balance, but if it's your first time, it should be zero. Now if you want to add some balance to your account, you can go to Polygon faucet and from there you have to connect your Discord first. And select Polygon ZK EVM Cardona from here, and now copy your wallet address from MetaMask and paste it here. I'm getting this error because uh, I already have some balance in my account, but if it's your first time, it should work. If it doesn't, you can try once or twice again and it should work. Now we will configure Remix. Remix is an online IDE for writing smart contracts in Solidity. Now first of all, go to deploy and select MetaMask, and it should be connected to your account. And now we are ready to code. First of all, create the file in contracts folder with .sol extension because we are using Solidity, and then define the Solidity version using pragma Solidity and version name. I am using Solidity 0.8, which is the latest version of Solidity at this time. Now we have to create a contract, and we are going to write all of the code inside this contract. Remember to name it same as the name you have given to the file. Now let's add some variables. We are using admin variable to store the address of admin, and ignore the threshold variable. I just forgot to remove it, but we are not using it anywhere in our code. Now I am creating a structure definition for policy and initialize a variable policies with it. Now I am defining two mappings here. We can use mapping to keep records of every user individually like we would do in a database. We will use voted variable to determine whether the user has voted or not, and we will use upvoted variable to determine whether the user has upvoted or downvoted. Now let's add events. Events are used to send data from the smart contract to the front end. For example, when someone votes on a policy, we can fire an event from the smart contract and it will update every client connected to the smart contract. Now here I am creating a modifier. We will use this modifier to check if the user is admin or not. If it's not, then it will return an error. We will use this in functions which we only want admins to use. Now I am adding a constructor. A constructor only runs once and that's when the contract is deployed. In this constructor, I am assigning my address to the admin variable. That means the account that will be used to deploy the app will be considered admin. Now let's add some functions. This function is called propose policy. It will allow users to propose a policy. We are taking title, description and category from the user, and we are setting upwards and downwards to 0 by default and implemented to false, and created and implemented at our timestamps. After pushing the policy, we are emitting an event. So when someone proposes a policy, an event will be sent to all the connected users and they can update their data. Now this function is called vote on policy. It will allow users to vote on a policy. In line 57 we are checking if the policy already exists or not. If the policy already exists, then it will return a warning. In line 58 we are checking if the user has already voted. If he has, then it will return a warning. After that we are checking a condition. If the user has upvoted, then we will increment the number of upvotes in that policy by 1, and we will set has voted to true for that user. And if he has downvoted, then we will increase the downvotes by 1 and set upvoted to false for that user. After this condition, we will set the has voted variable to true for this user, and then we will emit an event for policy voted. Now this function is called implement policy, and it will allow us to implement a policy. I have used a modifier in this function which we defined earlier, which was called only admin, and because of this modifier only the admin will be able to use this function, and if a normal user tries to use it, then they will get a warning. Now there's not much in this function, we are just checking if the policy exists or not. Then we just set implement it to true and then emit the event. Now there are two more functions: get total policies to get the number of policies, and get policy to get the data of a policy. So our contract is ready and now we are going to deploy it. So first of all, let's compile our contract. For that, go to the Solidity compiler and compile your contract. But before compiling, if you are using Polygon's testnet, then you need to change some advanced configuration. You need to select London in EVM version, because I ran into some errors when I tried to deploy my contract in Polygon testnet with other EVM versions, but London works fine with the Polygon testnet. Now after setting the advanced configuration, you can compile your contract, and after it's done you can go to the deploy section and deploy your contract. Now okay so I forgot to select MetaMask, so it's just deploying in Remix VM. It's the Remix virtual machine. You can use it to test your contract. You can see here it's deployed, and if you open it you can see all the functions. You can pass the values here to test these functions. Now we want to deploy our contract in Polygon testnet, so we will connect it to MetaMask, and now it's connected to MetaMask and we can deploy our contract now. So click on deploy and it will open MetaMask. It will take some time, and our contract is deployed now. Now you can open this and you can test these functions to make sure they are working. Let's try proposing a policy. So it was successful. Now let's try fetching the policy. So it worked and it returned the policy we just published. Let's try getting the total number of policies. It should return 1. Yes, it returned 1. Okay, so it's working fine. Now to connect our front end with the smart contract, we need two things. The first is contract address. So we can copy it from here. Make sure you copy it from here after you deploy, because the next time you open Remix, it could be gone. And the second thing is the contract JSON file. Go to artifacts and from there this file policy governance underscore metadata dot JSON. So let's start coding now. Now in this tutorial I am not going to explain you how to use Next.js, and for state management we are going to use Jotai, so you should already know that. So let's get started. So first of all you need this JSON file which we got when we built our contract, and we will use this to connect with our smart contract. And first of all we will define some atoms, and we are going to use these atoms globally in our app. Now let's go to layout. In root layout of this website we are using use effect to initialize web3 using this function. First of all we are loading web3 instance in this variable, then we are connecting our MetaMask account and loading our accounts in this variable, and we will store the first account in this atom, the account atom, so that we can use it globally. And then we are loading the contract. For contract we need the contract ABI and the contract address. So the contract ABI we can get from policy governance.json, and the contract address we already got it when we built our contract, when we deployed it. And after that we will set the value of contract atom to this contract instance so that we can access it globally. And then we will add event listeners. We added 3 event listeners. The first one was for policy proposed, the second one was for policy voted, and the third one was for policy implemented. So when someone proposes a policy, we will update to the policy atom, and we will append the new policy to the array like this. And when someone votes on a policy, we will find the policy that was voted and we will increment the number of votes. And when a policy is implemented, we will find that policy and we will change the implemented variable to true in that policy. Now here we are getting the address of admin, and we will check if the address of admin is same as our account address. If it is, then we will set is admin to true. And after that we are loading all the policies, and this function is defined above. We are passing contract instance and our account address. This is contract and account. And in this function, first of all we are loading the total number of policies using get total policies function. We will get the total number of policies, and then we are initializing this variable where we will store our policies temporarily, and after that we will use it here in set policies. Now in this for loop we will iterate for all the policies, and we will get each policy one by one and append it to this variable. You can see here we are getting the policy, and we are getting if the user has voted or not, and if the user has upvoted, and then we are pushing it to policy list, policy, voted and upvoted. So this is all for the root layout. Now let's go to the home page. In home page we are showing the account address of user here, and then here we are showing the implemented policies, and these are the policies which are not yet implemented, and this is the form which allows users to propose a policy. This is the home page. We are only using 2 global variables here, account and policies. Here we are showing this If the account is connected, then we will show connected to account, or else we will show button. If user clicks on this button, this will reload the window which will trigger MetaMask. After that, we are showing policies. We are just mapping all the policies and passing it to the policy card. And this is the form which allows us to propose a policy. Now let's see the code for policy card. So here we are using three variables: is admin, which will tell us if the user is admin or not, contract, which is the contract instance, and account, which is our current account address. So here we are showing policy title, category, and description, as you can see here. And here we are showing the number of upvotes and downvotes, and this is disabled if the user has already voted. So here I have already voted, so it's disabled for me. And the implemented button will only be shown if the user is admin, and I am the admin, so I can see this button. But if it's a normal user, they can't see it. Now let's see the vote function. First of all, we need to get the gas price. This function will return the gas price and it will be saved in this variable. Then we can use the vote on policy function. In this function, we are passing policy ID and is upvote, which we getting from the function, and we are sending it from our account, and we are paying this much gas for this function, and this is the current gas price. And if it runs successfully, then we will show a toast which says voted on policy successfully. And if we get an error, we will see it on console and get this toast. Now this is implement policy function. In this, first of all, we will estimate the gas price, and then we will implement the policy. We will just pass the policy ID from account, and this is the gas fee. Now let's see the proposed policy form. So I have used React hook form in this, and this is a normal form, nothing special. Let's see the on submit function. Here we are getting the data, and in data we have title, description, and category. Now first of all, we will estimate the gas price, then we will call the proposed policy function, and we will pass data.title, data.description, and data.category, and send it from our account. This is the gas fee, and this is the estimated gas price. I will put the link to GitHub repository in description. Thank you for watching. See you next time.